Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: what is the GenAI Life Cycle? The GenAI Life Cycle represents a structured framework guiding the development, deployment, and continuous improvement of generative artificial intelligence systems. Understanding this life cycle is essential in leveraging the full potential of GenAI technologies, which are reshaping various sectors by automating content creation, enhancing decision-making processes, and personalizing user experiences. This lesson delves into the intricacies of the GenAI life cycle, outlining its stages and their significance, supported by relevant statistics and examples to illustrate the transformative power of generative AI. At its core, the GenAI life cycle begins with problem identification and requirement analysis. This initial phase involves defining the specific problem or opportunity that generative AI can address. For instance, a financial institution might seek to use GenAI to automate customer service interactions through chatbots, enhancing customer experience while reducing operational costs. Precise problem identification ensures that the subsequent stages of the life cycle are aligned with the strategic goals of the organization. Following the identification phase is data collection and pre-processing, which is critical for the success of GenAI models. Generative AI systems rely heavily on large volumes of data to learn and generate content. The data collected must be relevant, high quality, and representative of the problem domain. For example, training a GenAI model for medical diagnosis requires diverse medical data, including patient records and diagnostic images. Pre-processing such data involves cleaning, normalizing, and transforming it into a format suitable for model training, ensuring that the model's outputs are accurate and reliable. The next phase involves model selection and training. During this stage, developers choose the appropriate generative model architecture, such as generative adversarial networks or variational autoencoders, based on the problem requirements and data characteristics. For example, GANs have been widely used for image generation tasks due to their ability to create high-quality, realistic images from random noise. Model training involves feeding the pre-processed data into the selected architecture, allowing the model to learn the underlying patterns and relationships within the data. This process can be computationally intensive and requires careful tuning of hyperparameters to optimize model performance. Once the model is trained, it undergoes evaluation and validation to ensure its effectiveness and accuracy. This phase involves testing the model on unseen data to assess its generalization capabilities and identify any potential biases or limitations. For instance, a language generation model might be evaluated based on its ability to produce coherent and contextually relevant text, as well as its sensitivity to ethical considerations such as avoiding harmful stereotypes. Validation helps in fine-tuning the model and making necessary adjustments to improve its performance, thereby increasing confidence in its outputs. Deployment is the subsequent stage, where the validated model is integrated into a real-world environment to perform its designated tasks. This stage involves considerations such as scalability, security, and user interface design, ensuring that the GenAI solution is accessible, reliable, and easy to use. For example, a deployed GenAI chatbot should seamlessly integrate with existing customer service platforms, providing users with intuitive and efficient interactions. Deployment marks the transition of the GenAI system from development to operational use, where it begins to deliver tangible benefits to the organization. However, the GenAI life cycle does not conclude with deployment. Continuous monitoring and maintenance are vital to ensure the long-term success and relevance of the system. This involves regularly assessing the model's performance, updating it with new data, and addressing any emerging issues or changes in the problem domain. For instance, a GenAI model used for news article generation may require regular updates to incorporate current events and evolving language trends. Continuous monitoring ensures that the GenAI system remains accurate, effective, and aligned with organizational goals over time. Moreover, ethical considerations permeate all stages of the GenAI life cycle. The development and deployment of generative AI systems must adhere to ethical guidelines to prevent misuse and unintended consequences. Issues such as data privacy, bias, and accountability must be addressed to ensure that GenAI solutions are fair, transparent, and socially responsible. Organizations must implement robust governance frameworks to oversee the ethical implications of their GenAI applications, fostering trust and acceptance among users and stakeholders. In conclusion, the GenAI lifecycle provides a comprehensive framework for developing and deploying generative AI systems that deliver substantial value across various domains. By systematically progressing through each phase, problem identification, data collection, model training, evaluation, deployment, and maintenance, organizations can harness the power of GenAI to drive innovation and efficiency. The integration of ethical considerations throughout the lifecycle ensures that generative AI technologies are developed and used responsibly, promoting positive societal impact. As the field of generative AI continues to evolve, understanding and applying the principles of the GenAI lifecycle will be crucial for organizations seeking to stay at the forefront of technological advancement. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.